Alright, now we have to tag the start, stop, reset, number of batches completed, current batch and plant status. So the start, stop, reset is similar to what we did in PLC box sorting. So in start, you can see the reset button is here. So we have to add few memory bits in the parallel. So for the reset, I'm taking B3 colon 0, 0 is already used. Let's start from 7 colon 0. I'm taking the series. So I can write SCADA start. This is P3 colon 7/0 for reset. Okay. So this is again a reset. So I have to just copy that here as well. So I'll just copy it, take a parallel loop and paste it here. This is a SCADA. I'm sorry. This is reset. SCADA reset. P3 colon 7/0. So I can take a tag here parallelly. Let's see, we can use reset tag, this one, P3 colon 7/0, 7/0, press enter. Enable read write mode. So this is the reset one, you can tag it here, P3 colon 7/0. Okay, now similarly for start and stop, so go back here. So let's see, the stop is here. So take a parallel run, and here B3 colon 7/3 is not used for stop from SCADA. B3 colon 7/3. So go back here for stop, you can find here B3 colon 7/3, press enter. So you can tag the stop here. Now for start, let's go back. Start is here. So take a parallel run and take a bit. B3 colon 7/6 is not used. SCADA start. So start we also have here. So take another parallel, copy that, paste here. Start is here again. Take a parallel loop, copy paste. So for start, B3 colon 7/6. So this is here, 7/6. Press enter and give the start to start. So these three has been tagged just like we did in PLC box sorting. Now number of batches completed, let's see its tag here. The number of boxes completed is in our subroutine, which is here N7 colon 0, number of boxes completed. This is an increment used by the last bit of the logic. So N7 colon 0 goes to, let me see, N7 colon 0, this logic is here. You can rename that to batches completed. Batches completed, just tag it here. Okay, so currently it shows 15 is the value in that. So 15 batches has been completed. If I go to online, you can see that 15 is here. Okay, now come the main thing, plant status. This I'll show you once I go to online. And current batch. Okay, so let me first go to online, download the logic, and meanwhile reset this environment. Okay, yes, online. Okay, now this is the main logic. So this time let's start this from the SCADA screen. So go to run. This is read write mode, reset, hard reset. So everything has been started. Now plant status. On plant status, what we're going to do is we're going to write three things. If the plant is idle or stop, when the plant is not running, or if it is filling. First status is plant is stop or idle. You can use idle. Idle is a more technical word. Plant is idle, nothing's going on. We can use the first status as idle. Second status would be filling operation, that it is filling the tank. So you can use filling. Third status could be mixing, when the mixer is on. Fourth status could be final draining. So we have 4 states in plant status. Alright, so let's do that first. We have 4 states here, so let's rename that state to, this is a multi-state indicator, idle, nothing is happening. Second state could be filling. Okay, third state could be mixing, and fourth state could be final draining. to copy. Now you can see this blinking operation because we have add a step here. This is 500 millisecond delay. First this will execute for 500 millisecond, it will be red showing final training. Then after 500 millisecond this will be colored as gray, or I can do this as green, and it shows final training again. Okay, press OK. So this is our plant status. Now how to indicate that I'll discuss. Next is current batch. We'll come to that addressing part later. Current batch means which is the current recipe. I have shown you this table. This is the recipe 1, recipe 2, recipe 3, 4, and up to recipe 19 we have here. Okay, so we have to write the current number of recipe. I can also show you the color. If I know the code of this color, I can directly put the colors here. So just for demonstration, I'm going to write the recipe. Okay, so here we need 18 steps. It is 3 steps. We need to add more steps here. So by going to plus. So what I'm going to do is I'm going to just write recipes, recipe 1, which is my white color. I know that, but I'm just writing the text recipe. Okay, and I'm not giving any color. This is my recipe 1. Similarly, this will be my recipe 2. This is my recipe 2. Okay, I don't want to give any color, so that's my recipe. Similarly, I'm going to write recipe 18. So I'm going to pause this video until I write the recipes, and then I'll get back to you. Okay, so I'm just pausing this video for a moment. Now this has been tagged with 18 recipes inside. So this is 18 state multi-state indicator. All right. Now if you see the logic here, you'll find the recipes. You'll find the position in the sequencer output, which will indicate which recipe is currently going on. All right. This is at position 6. Now if you see this current paint production here, this is the 6th recipe being created here. So once this recipe completes, this will switch to 7, which happens just when the mixer stop. Now this is 7. So 7 will be the recipe after this blue paint, this pink magenta paint. So this is the 7th recipe now. All right. So what we can do is, the simplest way is to read the position of the sequencer output, either this one or this one, because both are same. So the control register for the sequencer output is R6:5. Okay. So R6:5 you can see from here. Here you can find control register 6:5, and this is the position. So the tag is R6:5.POS. This is the tag. Okay, so you can copy this tag and you can paste, you can use that in the SCADA screen. Now this was the recipe, so let's create a new tag. So you can go to new tag, OPC tag, and you can write here recipe. Server will be same, or you can also read it from the UPS server directly. If you can find the control, or there's no position, this is 0, I can select 0 and I can change that to 5. Okay, click apply and click OK. So once this tag is created, we can just put this tag on this recipe. This is the tag, give it here. This shows current recipe 12. It is reading from here. It shows 11 here. This is the recipe. After this recipe, it will change to 13. This is changed to 13. So this was the recipe you can find from the tag R6:5.POS. Okay, I hope this was R6:5.POS. Similar way, you can also define the plant status, which is idle. Now this is showing 13, although this is 12 here, so I think there is some mistake in writing the numbers here. So at 13 I could have written 12. So this can be changed. So the idea is you can read the data register from this control register of the sequencer, which is 13. Okay, so you can rectify your error of the SCADA screen by changing the numbers. Right, now plant status. In this plant status we have 4 status. We have already defined idle, filling, mixing, and final training. Now if you notice the outputs in the ladder logic here, this is being changed. Now this is the register for the outputs, O:0.0. Alright, this is the word address. Now here if the mixer is on, this is 64. I can show you that again. In final training you will notice that this is 128. In the filling, you'll find different output. Now this what happening is, this is converting binary into decimal. For example, if in the mixer only actuator 6 is on, so 2 raised power 6 is 64. Hope this makes sense. 2 raised power 7 is 128. This is the 7th output. Okay, now in the next state you'll find 2 outputs are on, so 2 raised power this is the combination of 2 outputs, which is 20. So what we can do is, we have to use equalizer. If this is equivalent to 64, we can show mixing. If this resistor is equivalent to 128, we can show final draining. Third status was filling. If this is not equivalent to 64 or not equivalent to 128, this is filling, and if it is equivalent to 0, plant is idle. So if I stop the plant here, now you will notice when the plant is stopped, it will be 0. So once the plant is stopped, this is 0. So we have 4 states. So we need to write the logic for that. I'll go to offline. I'll use that in the end again, just to animate the plant status. So I can use a rung, and I can actually use that data register to move that into some value. Okay, because we are using here plant status idle, and we have to assign a data register to this element. All right, which we can assign N7:1, which is used for read. Now we need to assign a data register which is not being used here. So this idle could be given as, let me just check it, large box is N7:6. I can use this one and rename that to plant status. This will be N7:6. Apply and click OK. Okay, now we have to compare. So I can use a compare command. One is equivalent to source A O:0.0. This is the data register which we are going to read, which is going to tell us what is the number of output which is on. So we have seen 64 and 128. So if it is 64, this is the case 1. Copy that. I'll copy that. If it is 128, okay. Third case is if it is 0. Fourth case, if it is not equivalent to 64 or 128 or 0. This is the third case. So you can take not equivalent to command. So when this is not equivalent to, same data register 64, and you can take that in parallel. Copy that, paste here, not equivalent to 128 or not equivalent to 0. In any of the 3 cases, we need to move the value. Now we have used N7:6 on the SCADA screen. Let me go back to the SCADA screen, and if you see its status, I'll go that in detail. Idle, mixing, so the 0 is idle, 1 is filling, 2 is mixing, 3 is final draining. So 0 is for idle. So here, if it is 0, this is 0, you have to move. There's a move command. You have to move 0. This means it's idle. N7:6. All right. This is the plant status multi-state indicator address. Now copy that again. Paste it here. And paste it here. And paste it here. Okay. Now second is filling. Filling means when it is not equivalent to 64 or not equivalent to 128 or not equivalent to 0. You can move here 1. 1 means it's filling. Okay, this is just a, you can say, a way of writing the code. And if it is 64, it is mixing. So this is 2. And this is 3. When this is final draining. So that's the logic. Let's download and see the results. So currently plant status will be highlighted in the SCADA screen. So I'll go to run. Now go back to, so everything is stopped. I have to just press reset, start again. So you can see that plant has been started, and you can see its status here. We have to just tag it with N7:6. which I forgot to do initially. Wait, 7:6 is here. Oh, this is getting very slow. Wait a second, this is not coming. This is showing 1. Need to stop it. Wait. Yep. Now you can target. So this is showing you the status. This is filling, mixing and draining. So this is having a little delay. So that's why you cannot see the exact status, because I told you the SCADA has a delay, because we are using that in demonstration mode. Okay. So this is the complete status of your ITS PLC paint production in your ignition SCADA screen, with different plant status, recipe, number of batches completed, and your sensor signals in this process. And this is just because of the delay we are having some incorrect values here. Rest the logic will remain same. I hope this makes sense, and we'll see more video tutorials about analog in our next video. Alright, so this is the filling, and you'll find different status here again. Let me check the logic. 64 is for 1, this is for 3. Wait. I think we made a little mistake. We have to add that in series, not in parallel. That's why it is always 1. Put that in series. Yes, and then download. That was a little mistake. So let me just refresh it very quickly. Okay, go back to run, go back to online. So plant status is idle, and we can start the process again. So right now it's filling. Now it shows mixing. So it shows mixing. Then it will be final draining, and shows final draining. Alright, now the plant status is great. Now when I press stop, next cycle will not occur and plant will again go back to idle. So number of batches completed is 1, and this is at recipe 3. So you can see that plant is stop. Number of batches completed is 1, plant is idle. So that was a little mistake in the ladder logic. We have to put that in series, because if even the mixing is not on, final ring is not on, plant is not idle, then it will move 1. Okay, so this was the ladder logic. You can have a copy of this ladder logic and SCADA screen in the RAR file in the PLC secure downloads using your secure password. If you have any doubt, you can put me a comment, or you can write to us for any queries. Alright, thank you.